G'day guys. All right, so this is our second lesson on linear modeling. Second of 3 lessons. Remember, linear modeling is a specific type of mathematical modeling, which we talked about last lesson, that deals with linear relationships, straight line relationships, okay? And we're just going to do a couple of very typical questions. This is exercise 6G part 2. And these couple of questions should be enough, more than enough, in order for you to get the idea and to do the exercise. Now, this is going to take a little while going through these two, even though it's pretty straightforward. But if you understand what I'm doing after the first question, you might like to attempt the exercise. And then if you encounter difficulty, you might like to come back and watch the second question as well, or just watch them both. And you'll see that for this particular video, I've already got the solutions filled in, and I'm just going to talk through the solutions because I think it might save a little bit of time. Okay, so here's our first question. Water is pumped into a partially full tank, so a tank that already has a little bit of water in it at the beginning. The graph below gives the volume of water V in litres after t minutes. Okay. Question A. How much water is in the tank at the start? Well, at the start, quite often that confuses people. And typically a student might read that question and think, how am I supposed to know how much water is in the tank at the start when I'm not given any kind of figures in the question? Well, you are given a figure. You're given the figure when t equals 0. Think about it. How much water is in the tank at the start, okay? And at the start means when t equals 0. And how much water is in the tank at t equals 0? Well, you can see here that the corresponding V value, the volume, is 200. So when t equals 0, get rid of that, V equals 200 litres. Simple. Okay, question B. How much water is in the tank after 10 minutes? Well, let's look at our graph again. Let's go up from t equals 10 until we intersect our graph, and then go across to see what the corresponding V value is, which is 1,200 litres. So when t equals 10 minutes, V equals 1,200 litres. Question C. The tank holds 2,000 litres, which means that's its capacity, that's its maximum volume that it can hold. How long does it take to fill? Okay, so this is the exact same skill, except we've been given the V value first, and we're being asked to determine the corresponding T value. All right, so when V equals 200, what is T? So I'm going to draw a horizontal line from V equals, I said 200, I meant 2,000, sorry. A horizontal line from V equals 2,000 across until I intersect my graph. And then I draw another line down until I intersect the horizontal axis, where I can see that the corresponding t value is 18 minutes. So when V equals 2,000 litres, t equals 18 minutes. Straightforward. Okay, D. Find the equation of the line in terms of V and T. All right, so this skill goes back to, what was it, exercises 6D and D, okay? When you're asked to find an equation of a straight line, you need 2 ingredients, A and B, where A is your y-intercept and B is your gradient, okay? So let's take a look at our graph. Now, I just said y-intercept, when actually we don't have a y-axis, we have a v-axis. And we don't have an x-axis, we have a t-axis. But just to keep the equations straightforward so we don't get confused, I am going to use y and x And then once I find my equation in terms of y and x, I'll change the y into a v and I'll change the x into a t. This way we avoid having to use the gradient equation, gradient equals v2 minus v1 over t2 minus t1, which is just confusing. We're going to stick with y's and x's. All right, so the first thing we need is the y-intercept, which is our a value. And we can see there that the y-intercept is 200. All right, so y-int, which is a, is 200. And just like that, we're halfway already. Okay, now to find the gradient, we have the formula. Gradient equals y2 minus y1 over x2 minus x1. So we need two coordinates, an x1, y1 pair and an x2, y2 pair. Okay, well, this here is my x1, y1. So, and it doesn't have to be, but it's just a nice simple point that I can see has whole numbers for coordinates. So that makes it easy. So I'm going to just choose that point. Any 2 points on the line work. So that's 0, 200. The 0 is my x1. The 200 is my y1. And for this point here, that's another nice point on the line, but I can see other points that I could use. For example, this point here would work perfectly well. That is my x2, and that is my y2. Okay. So substituting those into our formula, we get (1200 minus 200 over 10 minus 0). So that's y2 minus y1 over x2 minus x1, which is 1000 over 10, which simplifies to 100. Okay, so that's our gradient. So we have everything we need now. We have a y-intercept and we have a gradient. So now we write the general form of our linear equation, y equals a plus bx. And for a, we substitute in 200. And for b, we substitute in 100. And we get our equation, y equals 200 plus 100x. And just remembering that we're not actually dealing with y's and x's in this question. We're dealing with the two variables v and t for volume and time. I'm going to change the y into a v, and change the x into a t. So I get the equation v equals 200 plus 100t. And that is that. Okay, we're getting towards the end of this question. E. Use the equation to calculate the volume of water in the tank after 15 minutes. All right. In other words, when t equals 15 minutes, when t equals 15, what does v equal? Well, we have an equation. V equals 200 plus 100t. And I'm going to substitute t equals 15 into that equation. So v equals 200 plus 100t, in other words, 100 times 15. 200 plus 100 times 15 is 1,700. 1,700 litres. And F. At what rate is the water pumped into the tank? In other words, how many litres are pumped into the tank per minute? Now that word rate is a dead giveaway, okay? Because whenever you see the word rate, when you're asked what is the rate of something, you're nearly always being asked to simply state the gradient. And a lot of students, never sort of realize how simple these questions are, okay? So we know that the gradient is at 100, okay? So the answer to this question is indeed 100 litres per minute. But let's take a look at the graph just to convince ourselves that that is actually the case. So how many litres are pumped into the tank per minute? Let's look at the graph. Might zoom in. Now, when 1 minute goes past, what does the volume increase by? Well, it goes up by 100 litres, okay? And then when another minute goes by, the graph goes up by another 100 litres. Another minute goes by, the graph goes up by another 100 litres, okay? So 100 litres per 1 minute. So we were correct. How many litres are pumped into the tank per minute? 100 litres per minute. In other words, the gradient. Okay, now that was question 1. For those of you who think that might be enough, you can go on to the exercise 6G part 2. But if you'd like to be taken through a second example, then stick around and we'll go through that right now. All right, question 2. The value of new cars depreciate with time, which is very true. Depreciate means decreases over time, okay? This is why cars traditionally are such a bad investment, okay? Because a few years after you've bought the car, its value has decreased significantly, okay? So the value of new cars depreciate with time. The graph below shows how the value, V, in dollars, of a new car depreciates with time t measured in years. Okay, straightforward. A, what was the value of the car when it was new? Once again, students find this confusing. What was the value of the car when it was new? Well, I'm not given any figures. How can I give an answer to a maths question when I'm not given any numbers? Well, when it was new, in other words, when t equals 0 years. And when t equals 0 years, I can see that the corresponding value is, well, it looks like $27,500, doesn't it? But I can't be 100% sure that that's not $27,400 or $27,498. So I'm going to say that the value of the car when it was new was approximately $27,500. That's what those squiggly brackets mean, okay? All right. B, what was the value of the car when it was 5 years old? Well, okay, when t equals 5, I can see that, the corresponding value is $15,000. And those values all align with this grid system. So I can be pretty certain that those figures are exact, okay? So in my answer here, what was the value of the car when it was 5 years old? I'm going to say exactly $15,000, okay? All right. Question C. Find the equation of the line in terms of V and T. All right, now, once again, I'm going to not use V and T until the end of the question. I'm going to use Y and X just to keep things simple so we don't get confused when we use the gradient formula in particular. All right, so for this question, let's take a look at the graph. Now, I can't be 100% sure that our y-intercept here is 27,500. I mean, I'm pretty sure it is, but just to be sort of mathematically rigorous, which means kind of strict, I'm gonna make the assumption that I don't know for certain that that is 27,500, okay? And so what I'm going to do is I'm going to use these values here that I am pretty sure are exact. I'm going to use those to find the gradient, and then using the gradient, I'm going to then find the y-intercept. And I'm pretty sure it's going to turn out to be 27,500. But just to be sort of mathematically strict, I am going to do it this way, all right? Trying to set a good example here. All right, so find the equation of the line. Now, in order to find the gradient, I need 2 points on the line, okay? And I've chosen these 2 points here that we've already dealt with. 1, 25,000 and 5, 15,000. There's nothing particularly special about these points. Any 2 points whose values you can be sure of, if those 2 points are on the line, then you can use those 2 points to find the gradient, okay? All right, so the gradient is y2 minus y1 over x2 minus x1. Okay, so y2 minus y1 or y2 minus y1. Doesn't matter what order you do it in. I've done it in that latter order. So 25,000 minus 15,000 over x2 minus x1, which is 1 minus 5. And if you simplify that, that comes out to negative 2,500. So a negative gradient, which is to be expected because our graph is going downhill. Okay. Now we have this general form of a linear equation, y equals a plus bx. Now I need to calculate a, the y-intercept. So in order to do that, I need a y value, a corresponding x value, and the gradient. And if I substitute those three into this equation, there will be one unknown value, a, and then I can go ahead and solve for a. So that's what I'm going to do. I've got my gradient, which is negative 2,500. And for my x value and my y value, I'm choosing this coordinate here. But it would work out exactly the same if I chose this coordinate here. Okay, so my x is 1, my y, corresponding y is 25,000. So I substitute those three numbers into y equals a plus bx, and I get 25,000 equals a minus 2,500 times 1. Okay, now I'm going to solve this by using my inverse operations. The opposite of negative 2,500 is positive 2,500. So I'm going to add 2,500 to the left and the right hand side of the equation, and I get a equals 27,500. And we are right there because we have a gradient, b, and we have a y-intercept, a, which incidentally is, as we expected, exactly 27,500. So we did a little bit of unnecessary work there, but it was good practice. All right, so turning back to the general form of a linear equation, y equals a plus bx, I'm simply going to substitute in my a value, which is 27,500, substitute in my b value, which is negative 2,500, and I get y equals 27,500 minus 2,500x, or v value equals 27,500 minus 2,500t. So we need to remember that if we're working with y's and x's to avoid confusion, at the last moment we need to switch them out for the actual variables in the question. Okay, so that's the relationship between the value of a car and the amount of time that has gone past in years. All right, we're almost there, guys. D, at what rate does the value of the car depreciate with time? In other words, by how much does its value decrease each year? And there's that word again, rate. So we know that the answer to this question lies within the gradient, okay, which is negative 2,500. So let's just confirm that. When every 1 year goes past, we can see that the value goes down by 2,500. Another year goes past, but the value goes down by 2,500. 1 year, 2,500. Okay, so indeed, the answer to that question lies within the gradient. So the answer is that the value decreases by 2,500 each year, and that is because the gradient is negative 2,500. And finally, is this finally? Yes. When does the equation predict the car will have no value? Well, once again, that's a sort of question students find confusing, because when means give me a time value. And students think, how am I supposed to provide a numerical answer to a question when I'm not given any numbers in the question that's being asked? Well, you are being given a number. You're told, you're asked, when does the equation predict the car will have no value? In other words, V equals 0, find the corresponding t, okay? Find the time at which the value is 0. So that's what we do. We substitute V equals 0 into our equation. Now our equation has two variables, okay? So if we replace the V with 0, then we're left with one variable, one unknown, and we can use our basic equation solving skills to find what that equals. So 0 equals 27,500 minus 2,500t. All right, now I want to isolate the t, so I'm going to add 2,500t to the left and to the right hand side of the equation. Okay, so I end up with 2,500t equals 27,500, but I want to know what 1t equals, so I divide the left and the right hand side of the equation by this coefficient here in front of the t, and I get t equals 11. So here's our answer. The car has no value, or a value of 0, V equals $0 after exactly 11 years. And that is the end. That was a little bit long-winded, guys, I know, but there's no real quick way to go through these things sometimes. So thank you for listening, and I'll see you next time.